That'll do. Let's debrief problem 9. This was very similar to the warm-ups we did. So what I'm testing is, can you look at the class that you've written here on the left and create objects, put them in a list, and then loop over the list and do something with all of the objects. So I've provided a starter template here. We're making a list of, in this case, rectangle objects. So I would have an array list of rect, because each element in the list is an entire object. It's not an int, it's not a string, it's a whole rectangle object. Okay, so I want 100 of them. So I'm going to need a loop that loops 100 times. And inside the loop, I'm going to need to run the constructor. So to run a constructor, I'll say rect_r equals new rect. And then what goes in the constructor? Well, I got to look over here at this constructor. So it's expecting 4 inputs. I'm supposed to give it the top left x and y coordinates and the width and the height. So I know that over here in this other file, when I run it, I'm going to need to provide it with 4 inputs. I haven't really given myself enough room here, but that's not really the point of this question that I want to focus on right now is running the constructor and putting things in the list. So let's pretend that we've got some variables and we're giving it the right 4 variables here. Once I've made my rectangle, then I've got to add it to the list. The list is named mylist, so I'd say mylist.add_r. And that's adding it to the end of the list. Okay, we'll come back in a second and look at what these random values should be. But this is the kind of basic template I want in your mind. Create an array list, loop a bunch of times, run the constructor to make the object, put the object in the list. Okay, so for the second half here, it says, well here, let's actually look at the other form, and then we'll look at the next part for both. So in this form, again, we're going to have an array list, but this time it's an array list of student objects. Just like last time, we want to loop 100 times. Oops, I less than 100, I plus plus. And just like last time, we're going to create a new student object. Student s equals new student, except this time, it's only expecting 3 inputs: the name, the percentage, and the block the student's in. So here I'm going to split this across lines. So we'll come back and fill in what are those inputs to the constructor, but then the last step would be mylist.add s. Okay, I guess let's go ahead and now fill in the bits. So the first input to the constructor is the name, and it says here the name is supposed to say like student 1, student 2, student 3. Probably the easiest way to do this would be, I guess let's do this. Here I'm going to make string n for name, or I'm going to call it, I want to emphasize that the variable that I use here is its own variable. It doesn't have anything to do with the variable name n over here. So I'm going to create a string called Bob, but it's going to be, and Bob is just arbitrary, but it's going to be the word student followed by the number I plus 1. Why I plus 1? Well, I starts at 0, but we want the first student to be named student 1. So 0 plus 1 is 1, and if you add an integer to the end of a string like this, it will coerce this to be a string and append it. Append means it's just going to attach it to the end of the existing string. So each time through the loop, Bob is going to be a new string that's going to be student 1 and then student 2 and so on. For the other ones, let's see. Random grade percentage between 0 and 100. That's a double. I can tell it's a double because it says so over here. So double G. And then because it's a double, I don't need to cast to int. Instead, I'm just going to say math.random times 100. I know here it says inclusive. It doesn't really make sense to be inclusive if it's a double. Some people did something like add 0.000001, which is okay. It's more like this is my mistake. I shouldn't have said inclusive here. Okay, and then the last one, a random block between 1 and 7. So here int b equals, here we do cast to int math.random. So I definitely want the smallest block to be 1. Let's think about what I could multiply this by. So if I had this as 6, that means I can't quite get to 6. And then when I add 1, that means I can't quite get to 7. So that's not what I want, because I want to include block 7. So that means this has to be 7. That means here, with this by itself, I can't quite get to 7. But then I add 1, which means now I can't quite get to 8, which is perfect, because then when I cast to int, I'll chop off the decimal, and 7 is the largest integer I could achieve. All right, so now that we've got all that, Bob is the input, then the second is the percent, which is g, my variable g here, and the last is the block b. Okay, so that would be a great answer there. Let's look at the part B for all of these. So here in part B, it says, save the last student in the list into its own variable called Sally. Let's just do that much. So if I'm saving a variable, it's a student variable. It's supposed to be named Sally. The list is called my list. Here I know how long the list is. So when I say get, this is the index that I want to get. If my list is length 3, then the last element is index 2. So a conventional thing would be to say mylist.size minus 1, because that's going to tell me 1 smaller than the number of things, and that's the last element. Because we know that the list is 100 things, in this case, it would also be fine to say 98, because that's the last thing in the list. Why 98? If there's 100 things, 99. If there's 100 things, then the last thing in the list is 99. Okay, so I've got my last student in the list. Now let's loop over all of the other students and see who is able to study with Sally. So most of you don't know about the for each loop yet. The for each loop is going to be a better way to do this, but for now, let's just loop over everything else. So I'm going from 0 up to 99, but not including 99 because that's Sally, and I already got student 99 out. So the pattern is, to get each thing in the list, student s equals mylist.get I. So now I've got an element out of the list, and now I want to ask if it can study with Sally. So we've got this method canStudyWith over here. But notice canStudyWith is a method that's inside the student class. So what that means is that to run it, only a student object can run it. I can't just say if canStudyWith. I have to have the name of a student and then dot canStudyWith. So it doesn't matter what order you do them in. I could say, Sally, can you study with S? Or I could say, S dot, can you study with Sally? Either way. Let's do it that way. So Sally.canStudyWith means that this object is the one running that method. And then you can see that the method is expecting another student as an input. So S is going to be the name of the other student. So if Sally can study with S, that means I want to print S. So this is system.out.println, and I can just have S right here. One of the things that I said in the summer homework was the toString method gets run automatically when you put a variable containing an object inside a print statement. So I don't have to say s.toString. Several people just ran toString without any object at all. Several people didn't have a print statement. They just said s.toString, and then their toString method just returned a string. But if it returns a string, in order to display it, it's got to be inside a print statement somewhere. So all of that wouldn't have worked. This thing that I scrabbled out, that's the correct thing. So system.out.println s. Okay, let's see. Let's close the curly brace, and that's the end. Let's look and see what that same thing looks like for the other form. For the other form, remember we had a list of rectangles. So here, loop over all the rectangles in the list and display the sizes of those that have a larger perimeter than the first one in the list. So if I wanted to, it's not required, but let's name a variable first. That will be mylist.get0, because 0 is the first index in the list, so it's the first thing in the list. Now let's loop through all the other things. So I starts at 1, I is less than mylist.size, or you could just say less than 100, because there's 100 things in the list. And just like last time, let's do rect r equals mylist.getI. So this is now going to get each rectangle in the list out one at a time. And then again, I want to ask which one's got a larger perimeter. Some people actually used the get perimeter method to get out the perimeter of one and the other and compare them. Notice that is larger than already compares to rectangles based on perimeter. So it would be a little bit nicer to just say first dot, wait, what am I trying to decide? I'm trying to decide if the other one has a larger perimeter than the first one. So let's do if r dot is larger than first. So if the other rectangle, so that's the one that's going to run the is larger than method. And now the input is the first rectangle. And so if it turns out that this other rectangle is larger than the first one, then we will s out r. And just like the other time, this runs the toString method. Cool. So let's close the for loop, and that's the end of that one. Okay, I hope this was helpful. I think the major things that people were missing, some people, just didn't remember to add their rectangle to the list. Some people weren't running constructors correctly. A lot of people didn't get this idea that if you have a method that's defined inside an object class declaration, then an object needs to be the thing running the method. And then you have to pay attention always when you run a method to what will the input be. So you look at the method declaration, see what the input's supposed to be, and make sure you're providing something that makes sense. And then the last thing was, how does toString actually work? It gets run automatically when your object variable gets put inside a print statement. Okay, I hope that's helpful. Mostly there's already practice for these that exist, but maybe I'll try and make a few more. Good luck.